This video covers everything we did in math today on Tuesday, March 8th. Open up ClassKick so you can follow along and pause this video to complete the Do Now on slide 1. You're opening up ClassKick, pausing this video, and completing the Do Now on slide 1. Before you resume watching the video, you should have completed the Do Now. This week's foundational learning target reviews adding and subtracting positive and negative numbers. You can check your work for the Do Now in today's notes, which are posted in the main Tuesday folder. If you need extra support and practice on adding positive and negative numbers, you'll find it in Delta Math under this week's homework, which is week 6. In class today, we finished lesson 8, which we started yesterday. If you were absent yesterday, you should return to the Monday folder and complete the asynchronous work for Monday first. Today's learning target is I can write and solve an equation that describes a balanced hanger diagram. Yesterday, we saw situations where we were provided a hanger diagram and a matching equation. We then had to solve the equation, or find the value of x. Today, we'll look at situations where we have to write our own and then solve for the variable. Let's take a look at slide 3. The directions say, explain how to figure out the weight of x by reasoning about the diagram and reasoning about the equation. Your first step is to write an equation that represents this hanger diagram. Go ahead and pause this video to write an equation that represents the hanger diagram you see here. If you need a hint, you can move to the last 2 slides of your ClassKick, which will show you the lesson summary for lesson 8 and give you some examples of what it looks like to write an equation that represents a hanger diagram. In this equation, we can see that the right side is 16 because that's the only box that we have on that side of the hanger diagram. On the other side of the hanger diagram, we have 2 groups. Those 2 groups include 2 x's and 2 5's. We can write the equation in a few different ways, but the dotted circle around each group of x and 5 gives us a hint that we'll be using parentheses. We have x plus 5, but it happens twice, and so I'll multiply x plus 5 times 2. Notice that I'm simply placing my 2 next to my parentheses on the left. That signifies multiplication. I could put a dot there to show that I'm multiplying 2 times x plus 5, but when a number is hugging parentheses, we automatically know that it can be interpreted as multiplication. 2 groups of x plus 5 is equal to 16. That's your equation. The next step is to find x. Remember, finding the number that x is equal to is the same thing as solving an equation. It means that you're finding the number that you can replace the variable with to make the equation true. Pause this video and see if you can find what number we can replace x with. There are a few different ways that you can think about this diagram. One of them is what we've been calling the chop method. We can take away the 5's from the left side of the diagram. But remember, we've got to keep that hanger in balance. So if I take away 2 groups of 5 from the left, I want to take away 10 from the right so that my hanger doesn't tilt in either direction. If I take away 10 from each side, on the left side, I'm left with 2 x's, and on the right side, I'm left with 6, because I took away 10 from 16. And so I know that 2x is equal to 6. I can use inverse operations. 6 divided by 2 equals 3, and I know my solution is x equals 3. Now, we can also find the solution using just the equation. And you can always pause the video here if you want to add to your notes on the diagram piece. Using just the equation, we see that 2 times whatever is in the parentheses is equal to 16. That gives us a hint that the inside of the parentheses has a value of 8, because I know that 2 times 8 is equal to 16. And so I can tell that x plus 3 is equal to 8, because x plus 3 is the value inside the parentheses. And again, I know that the inside of the parentheses is being doubled for a product of 16. I can use inverse operations to find x, which again is equal to 5. You have a second example of writing a hanger diagram and equation on slide 4. Go ahead and complete slide 4, and you have access to the lesson summary on slides 6 and 7. Once you've completed these slides, you're all set for makeup work on Tuesday the 8th, and your homework for the week is posted in Delta Math.